Welcome! We will analyze a simple but sneaky card game, and then prove a neat divisibility fact. First, the game. There is a shuffled deck of numbered cards. The dealer reveals 4 distinct cards in order. Call them A, B, C, and D. If the values appear in strictly increasing order, meaning A is less than B, less than C, less than D, you win $10. Otherwise, you lose $1. Let's build an intuitive picture. Now, here is the key insight. Once 4 distinct cards are drawn, there are 4 factorial possible orders, and they are all equally likely. 4 factorial is 24. Only one of those orders is strictly increasing. So the probability of winning is 1 out of 24. Let's turn that into numbers. The probability of winning is 1 over 24, about 4.17%. The probability of losing is 23 over 24. Your expected value per play is $10 times 1 over 24 plus negative $1 times 23 over 24. That equals negative 13 over 24, approximately negative $0.54. So on average, you lose about 54 cents each play. Does the deck size matter? As long as you draw 4 distinct cards without replacement, the orderings of those 4 are still all equally likely. So the probability of a strictly increasing order is still 1 out of 24, whether the deck has 50 cards, 100 cards, or any size at least 4. Now, for a quick number theory gem. We will prove that for every integer n greater than 0, the number 10 to the n plus 1 plus 10 to the n plus 1 is divisible by 3. That is, 10 to the n plus 1 plus 10 to the n plus 1. Let's write the statement. Base case, n equals 1. 10 to the 2 plus 10 to the 1 plus 1 equals 100 plus 10 plus 1, which is 111. 111 is 3 times 37, so it is divisible by 3. Inductive step. Assume for some n at least 1 that 10 to the n plus 1 plus 10 to the n plus 1 is divisible by 3. We must show the same holds for n plus 1. Write the next term as 10 to the n plus 2 plus 10 to the n plus 1 plus 1. Now observe this identity. 10 times the assumed multiple minus 9 equals the next term. Since 10 times a multiple of 3 is a multiple of 3, and 9 is a multiple of 3, their difference is a multiple of 3. That completes the induction. There is also a one-line shortcut using modular arithmetic. Because 10 is congruent to 1 modulo 3, any power of 10 is also congruent to 1 modulo 3. So 10 to the n plus 1 plus 10 to the n plus 1 is congruent to 1 plus 1 plus 1, which is 3, and that is 0 modulo 3. Done. Summary. The card game has probability of winning 1 out of 24, and a negative expected value of about negative $0.54 per play, regardless of deck size, at least 4. And the divisibility fact holds for all positive n. Great work!